Okay, I think that 5-minute buffer is enough and we can begin this webinar. Hello, everyone. Thank you for joining us today on this interesting topic. Today, we will have Traice, who is part of IW Connect for more than 3.5 years, almost 4. He is part of our DevOps department, and I can say that he is a great professional that has been evolving during all these years. Today, he has an interesting topic to talk about. He will talk about one-click deployment of an ELK-based monitoring solution using Terraform and Kubernetes. So without further ado, Traice, you can begin.
Thanks, Renata. Like Renata said, I'm Traice Traikov. I'm part of the Interworks team for IW Connect team for more than 3.5 years. I have total experience of more than 5 years in the IT department. And in this presentation, this webinar, I'm going to show you my proof of concept of how you can do create an infrastructure and deploy your application in Kubernetes with basically one click. So like Renata mentioned in the agenda for this webinar, basically we are going to look into the concept of how what is infrastructure as code and how to use its potential to help in building your infrastructure for your environments, for your organizations. So in order to start this, I have basically the question is, what is infrastructure as a code? Infrastructure as a code is basically very self-explanatory. It's basically infrastructure written in a code. So what that means? That means you can write a particular set of codes with commands and functions, and with that you can create a lot of the infrastructure components like network adapters, network configurations, virtual machines, and even databases, etc. So in the question, why should we use infrastructure as code? During my research, I stumbled on one quote that really caught my attention. Treating your infrastructure just like any other pieces of code creates a programmable infrastructure that allows you to take full advantage of the scalability and reliability of the cloud providers. What that means in that by writing your scripts in one of those infrastructure as code tools, you can basically configure and work with your infrastructure and unveil the full potential of the cloud provider. The benefits, there are a lot of benefits for using infrastructure as code. In my experience, I can name a couple of them. First off is the cost reduction, which is very crucial for every business environment, because if you are reducing the cost of everything that you pay for, basically it's much more helpful for the organization and for the whole business management side. With using infrastructure as code, instead of you having a larger team to manage and maintain your infrastructure, this can be shrinked to a very small team, or even by individual in any use cases, where he themselves can manage and update the code whenever it's necessary. Also, a very crucial benefit is having a version control, because every infrastructure as code is just like an application or any type of programmable code, which means you can track your progress and your commits history throughout the whole project lifecycle, your infrastructure lifecycle. Also, it's very simplistic to use and very compatible for a lot of providers. Simplicity in the way of simplicity, that means that you can use it as basically what are you doing is writing down a script and then executing it, which will create your databases, your virtual machines, your network adapters. You can configure a lot of your network or database configurations just by running that script. And it also, the infrastructure as code tools are, most of them are standardized, so that will help you reduce your potential for any errors, which means every infrastructure as code tool can be is creating your infrastructure using a standardized way. During my research, I managed to split all of my work in 5 stages. They're basically the one that you are seeing on the screen. The first stage is develop, is where you develop your scripts and your code using some text editors like VS Code or Atom or whatever of your preferences. And after you are working on your code, you can always commit and save your code in a local or remote repository. For the build stage, you can use a lot of building tools to build your code. For example, if you are creating containers in Docker, you can use tools to create your Docker containers, and your Docker containers then can be published to a Docker container registry like ECR on AWS or Docker Hub, which are 2 of the most famous repositories for containers. And after you're publishing your code, you can deploy it to your environment by basically pulling it from your repository. One of the infrastructure as code tools that I had experience working with is Terraform. And Terraform provides you with a lot of, and it's very popular at this time period. It provides you with a lot of well-written documentation. Very also, it's very much easier to use, and the syntax is much more user-friendly, should I say. Also, I'd like to mention that Terraform is cloud agnostic, which means you can run your resources and create your infrastructure on any cloud providers like Google Cloud, AWS, Azure, or even Alibaba. One of the main keys in using Terraform is his reusability, which means you can reuse your code, and you don't have to write it down from scratch every time you create a new project. And also Terraform has official modules that are helping you out to shrink your code, and instead of you use resources instead of you use modules instead of resources, which means you can use more you can write less code and develop and create more of the infrastructure. Right now, I'm going to show you what we're going to build using our Terraform scripts. I'm just going to go and open my workflow design. So basically, I believe you're seeing the screen, right? In my case, you can use either an on-prem local server, or you can run a Docker container with already pre-built credentials for AWS and all of the necessary tools to run Docker and AWS commands. And with the code that I'm going to present later in this demonstration, we are just running the command Terraform apply. And with Terraform apply, we can create all of the infrastructure. So in my case, the infrastructure code is split into two deployments. One is the AWS deployment, and one is the Elastic Cloud deployment. This is Elastic Cloud Managed Service. They are also official providers for Terraform. And with the first step, we are going to create a VPC that will contain 6 subnets, 3 private and 3 public subnets. And in one of the public subnets, we're going to have a NAT gateway that will manage the whole traffic inside the VPC and directed outside the VPC through the internet gateway. Then we're going to create an AKS cluster that will be outside of the VPC, and we're going to attach 3 working nodes, which will be an EC2 instances that will be deployed in 3 different private subnets. When the worker nodes are up and running, we will run a kubectl deployment on those 3 working nodes, where we are going to install the Elastic agents or daemon sets, file bit and metric bit, that will help us monitor and extract logs from those nodes. And that will be all of the AWS deployment. And alongside the AWS deployment, we are going to create an Elastic Cloud deployment. That is a much more standard deployment, because Elastic Cloud allows you to use a deployment templates that will, let's say, for testing or production purposes, it can be much more simplified. Now I'm going to go through the code so that you guys can see what is basically. I can do a short walkthrough to it. Like I said, we are using modules instead of resources. This way, the length of the script will be much more easier to manage and to read, so you can understand what is basically going on. So here is, I'm using VPC module, which is an official module from AWS. And as you can see, I'm already creating 3 public and 3 private subnets, and I'm enabling the NAT gateway. After that, I'm creating the EKS cluster. I am setting up what type of Kubernetes version it should run, the cluster version, and to what type of instances do we need, and how much nodes are we going to require for this process. Other than that, we are going to create some other applications and deployments, such as Elastic file storage, Jenkins, and we are going to deploy our modules, file bit and metric bit, which are, like I said, the daemon sets for this, so in order to export all of those metrics and data to our Elastic Search service. At last, as a dependency, we will need to deploy kubestate metrics, which that API is going to help us harvest information for the deployments and the replica sets, and how much of the state, and what if there are any changes in the states of the deployments. With this, we are going to create the whole infrastructure basically by using the Terraform apply command. And after that, we are going to do some automated dashboard imports into that, or they are already pre-built, and you can just import your dashboards and prepare your monitoring and log solutions in order to, you can start checking and monitoring the health of your Elastic Kubernetes service. So I'm just gonna go and to the next slide, and we are going to the next stage, which is deploying our e-commerce application on AKS. So I'm just going to walk you through the whole steps that we are going to do. This is an automated process using a shell scripting. So we have two shell scripts that are going to do all of our work and deploy all of our necessary application and all of its dependency. So first, we're going to create our images with the latest version of the application. We're going to create the Docker tags, and then we're going to push it all of those to the Elastic Cloud, Elastic Container Registry. And when we are done with the push, we are going to create a from our AKS cluster. We are going to basically pull all of the containers from that registry. And after we are deploy all of the applications, we are going to deploy an Nginx ingress controller that will help us handle the load balancer. And I'm just going to go back to the code. I'm going to go straight to the deployment part. And like I said, we are using shell scripts in this case, but this can be done with some tools like for continuous integration and continuous delivery, like Jenkins, Circle CI, Git Actions, and but also you can write your own scripts in Python or Shell or PowerShell. It depends on what environments you're working and your preferences. So here I'm gonna walk you through what we are basically doing with how we are creating an image and how we are doing. Like you can see, this is a parameterized script where you have to set up your parameters in order to run the script. This is basically how you can create your image tags. You can create your use the command docker build and docker push to your destination, and after that we are going to deploy all of those into your cluster. So here is this is also a parameterized deployment, which means you have to set it up parameters like what type of cloud provider are you using? Are you using the cloud provider like AWS, Azure, or you're doing it on your local machine? Also, do you want to install the ingress, or you do not? You already have an ingress set up. It gives you that choices right away on the beginning before you run that script. Basically, as you can see, a lot of the commands are for kubectl apply, which means you're going to create those deployments, and also if you can use the same script to delete all of the deployments on your AKS cluster. And with this, I'm going to go to the next slide, where we're going to talk about our monitoring and log management. Like I said, we are using Elastic Stack in this particular case, and we decided to go on a managed service instead of we deploying it in our on-prem environment, because Elastic Stack, Elastic Search service is quite famous. A lot of big companies are using this platform for a lot of purposes, including monitoring and log harvesting. It has a very respectable SLAs and a very good support. Depends on what package you are subscribed to. Their lightweight agents, like we said, are pretty not very demanding in hardware, so you're not going to spend a lot of resources for that deployment. And also it has very well-written documentation that helps you understand and navigate through all of the product. And also one very crucial thing is that it has very easy. It's very easy to integrate with other services. Now that I mentioned that we already have the deployment done with our Terraform script, I'm going to go and show you how the dashboards are looking like. So give me a second. So here is the logging dashboard. As you can see here, we already have a search that is pre-built with our that shows you in what the Kubernetes namespace this is information, this message is from. You can see the message, you can see from what pod it's coming from, and what is the time of the execution. So here you can see a lot of those logs that are coming through from the file bit, and you can see that the activity here. And of course, you can use the search button to filter your search, to filter to the things that you want to investigate or monitor it in a much more versatile fashion. This is for the logs, and this is I'm going to show you now our host dashboard. This is basically, like you see, I'm already filtering it out, and I'm searching for a certain host. So this is one of the nodes that we deployed with our Terraform script, and you can see all of this, the information that you need, like the CPU usage, what process is taking much of your user of the node, how many processes are total, how many memory usage from total memory is used. You can see it in a percentage way. You can see how much of the disk is used in a percent. And also here you can see a little more history of how, if there are any spikes in the last 60 minutes, and you can check what process and what pod is taking most of your memory. This is more on a host. This is a representation for a certain host. Here I'm going to show you a representation of there is much more, should I say, Kubernetes native. So as you can see, how much deployments do we have right now in our Kubernetes cluster? How many nodes there are? How many pods? How they are desired, which means for how much pods that there should be, and how from those desired pods, how much are available and how much are unavailable at this point. Which is right now it's working very good. And here you can see the network node, like a historization in the last 1 hour. If we have any, what is the network packages that are going in and out. And here you can see what pod is basically the most that use this in the way of memories. How many memory, how much memory it's used, and how much CPU is used per pod. I'm gonna switch back to this presentation here. I believe we managed to cover most of our presentation here. So feel free to ask any questions that you like to know, and we can start with the discussion.
Raja, thank you for the wonderful and insightful presentation. I believe that it was very useful, and it will be an interesting topic to think about even after the webinar. We have a Q&A tab where all of you can ask your questions. We already have one question from Darko. He says, I have a question regarding Elastic Search. How do you handle the licensing change for your usage?
Well, basically, we are, like I said, Darko, we are using more of this is for presentation only. So I'm using a free license right now. But that, like I said, this is a very interesting topic to discuss for Elasticsearch. This is something that I should say. It all depends on your on what is the scope of your need to use Elasticsearch. So it depends. It really depends on your of the how big your project is. What is your demand in Elasticsearch? And it's basically more of a debatable question instead of a straightforward answer in this way. Yes, the alternative for using, let's say, a free license on premise is that they have a lot of plugins right now. So Elasticsearch use a lot of plugins. They are free to use, and so most of them are very useful. And of course, if you use it as a free on-prem solution, maybe the managing with the plugins it's a little tricky, should I say? But the managed service provides you with the full capacity to use the Elasticsearch service. But like I said, the community is pretty vast and has a lot of plugins that can help you with your, let's say, with your need of with your scope of the project.
Thank you, Traian. I believe that answered the question basically. So it means it depends on the project and on the needs.
Yeah.
We have another question. Is there any option to automate dashboards in Kibana?
Yeah. Basically, you can. One of the things that you can use is you can pre-build your Kibana dashboards, and then if you use the Kibana API, you can automatically create an automatic job to deploy all of your dashboards. So the documentation about the Kibana API is pretty vast, and basically what you can do is you can create one dashboard, and you can reuse it and deploy it as a part of a job, or it's basically a curl command that you can automate and then use it to every working space, other Elasticsearch instance, or other Elasticsearch deployments, etc.
Thank you. I believe that answered your question. We have another question. With what external systems can Kibana be integrated?
Kibana has already a lot of services that are easy to connect with. They are called connectors in Kibana, which such as Slack. You can use PagerDuty. You can use any type of email server. You can use Jira, and with that, basically, if you're using the managed service from Elastic Cloud, you have all of that inside built into your Kibana system. So it's very easy to use, and it's very easy to create that kind of connector. So you can create alerts, you can create tickets in Jira, and you can even set it up to call. If you're using PagerDuty the connector, you can set it up even a call for if there is an issue or an outage in your system. That you can create an automatic call that will call you up every time there is an issue and some of the threshold is getting exceeded.
Thank you, Traian. We have another question from Zoran. You mentioned the daemon sets for FileBit and MetricBit. How they are different from deployments, and why are you using them for these services?
Sorry, let me see the question again.
It's not in the Q&A. Please,
Okay.
I would ask the audience to please send us your questions in the Q&A tab, not on the chat. Thank you.
I'm going to open the chat.
It's basically about diamond sets.
Oh, okay.
How they are different. You mentioned them.
Basically, when you use monitoring solutions like FileBit and MetricBit, the best way to run them are as daemon sets. The main difference between a deployment and a daemon set in this particular case is that when you deploy a deployment, you can use a deployment, then you have to you can configure how many replica sets do you want in your configuration. So that means that you if you expand your or auto scale your or scale your cluster, let's say from 3 nodes to 4 nodes, you have to switch it up to from 3 replica sets to 4 replica sets, and that needs a more configuration from your side to do that in order for you to have those type of information to get it. But with daemon set, they are running basically on every node you have a daemon, which is like an agent that is exporting all of the information that you need. If it's metric bit, it's going to be metric data. If it's file bit, it's going to be log data. So that's why in this case, and for any monitoring practices, it's much better for you to use daemon sets instead of deployments.
Thank you, Traice, for the thorough answer. Do we have any other questions? Feel free to ask them now in the Q&A tab. Of course, you can contact Traice afterwards as well if you have another additional questions related to the topic. But if you have something else that can be answered, feel free to do so in the Q&A tab. Oh, here is your address if anyone wants to contact you after this.
I think we have one more question. Oh, no,
yes,
two.
Did you try Amazon open source fork of Elasticsearch? And if you do, what are your experiences regarding it?
Yes, I tried the OpenSearch Elastic service that is on AWS, but it's no way the same as using the Elastic Cloud, because a lot of those let's say perks using Elastic Cloud are unavailable. So at the starting, from my experience, at the starting from working on this proof of concept, I tried to work with OpenSearch instead of Elasticsearch service, and I've seen that a lot of things that are missing. So basically, they're using a fork version of 7.10, I believe, and which is not the same one. And Elastic Cloud has up to 7.15 right now. So it's a very it's much older version. I believe they're still on running on Apache, and Elasticsearch right now is working on a different web server. So also, I had some more troubles working with OpenSearch, and I wasn't really comfortable working with OpenSearch because a lot of the features were missing from the Kibana and from the Elasticsearch. I see one more question. Yeah. Can I run a Kubernetes application in any cloud provider? I believe so, because Google Kubernetes service is native for Google Cloud, and also it can be run as a Elastic Kubernetes service in AWS and AKS in Azure. So I believe the 3 biggest one are covered, and I believe that there's also support and a lot of documentation for other cloud providers.
Thank you, Traice. Do you have other questions? Anyone from the audience want to know something else? I don't see any other questions or comments, so I think that we can slowly finish this wonderful webinar. Thank you, Traice, again for putting this together for us and for the audience that is working in this field. I believe that it was very useful, and I'm sure that we will have some following DevOps talks where we can share ideas or experiences and get to help people solve problems that we already have. So thank you again. Thank you everyone who spared some time to be with us this afternoon. It was a great turnout, and we hope you liked our presentation. From me, have a great afternoon.
Thank you, Renata. Thank you, everybody. And I really appreciate your presence here. And I'm looking forward to chat with you guys and have a healthy discussion about DevOps and all of the practices that we are basically sharing as a professionals.
We see some comments that you had a great presentation.
Thank you. I really appreciate it.
That the audience liked your presentation and your subject. It was really nice and interesting. So thank you again. Thank you, everyone. And we will see each other very soon. Have a great afternoon.
Thank you.
Bye-bye.